cannot forget about f prime of x being limit as h approaches 0 from f of x plus h minus f of x divided by h. We cannot forget about this one. On particular functions, we will still have, I would still would like to use it and show you how we get to a particular derivative. But in this chapter, we will be able to use differentiation rules. So there are a few very important functions. For example, let's look at f of x, which is the square root of x. And let's say we want to find f prime of x. Also, for f of x equals x squared. And also for f of x equals e to the x. For these, I will illustrate with a definition. And moving forward, we will use the formula, the differentiation rule. But I need to convince you and make you understand where these are coming from with a definition, before I just give you a formula to remember. Okay, so let's start with this. I'm going to use the definition of the derivative, the only definition we have for the derivative, on these three functions. Let's start with the square root of x. So f prime of x is limit as h approaches 0 from the square root of x plus h minus the square root of x divided by h. We've seen this several times before, or something similar to it. And we know how to determine this limit. Of course, I will plug in 0 for h, and of course I get 0 over 0. There is no discussion there. So then what do you think we have to do next? What is our next step? Correct. So the square root of x plus h plus the square root of x, the square root of x plus h plus the square root of x. So this is limit as h approaches 0. I will copy the denominator, and I would like you to tell me what happens in the numerator.
X plus h
Yes.
minus x.
Excellent. That's exactly what happens. And these two go away because they are positive and negative x. And then eventually, I'm going to write it one more time. H divided by h, the square root of x plus h plus the square root of x. And yes, as we know, every time we calculate, determine, simplify the difference quotient, that h from the denominator must go away, and it does. So only now, notice that the limit operator is present at all times, but now I can drop it. Because at this point, I will calculate the limit. So can anyone give us the answer?
1 over 2 squared.
Do we all agree with 1 over 2, the square root of x?
Mm-hmm.
So actually moving forward, we have to remember this. Now we saw it, we proved it together, and but moving forward, you can always reconstruct the proof, but I'm hoping that I convinced you of this, or you convince yourselves of this. Any questions? Is this okay? Everyone?
Mm-hmm.
Okay, so let's look at the second function then, with the same definition, of course. So f of x equals the limit as h approaches 0 from x plus h squared minus x squared divided by h. Of course, again, it's 0 over 0. Of course, I'm hoping that all terms without h will go away from the top, and that h in the denominator somehow disappears at the end, or towards the end. So can anyone give us the next step? Let's limit as h approaches 0.
Expand it.
Yes, please.
X squared plus 2hx plus h squared.
Very good. Of course. So, as expected, those terms without h went away. And as expected, we will factor out an h. That will remove the h from the denominator. So can anyone tell us what is left at the top?
2x plus h.
And finally, we can determine the limit, and we can drop the limit operator, which is
2x.
Very good. So now moving forward, I hope that we will all remember this. We proved it together, and we should be able to use it moving forward. Now, in general, so this was specifically for x squared. In general, let's differentiate it. This is our first rule. Let's differentiate x to the nth power. Notice what happened here. We moved 2 in front, and we subtracted 1 from the power. So then we move n in front, and we subtract 1 from the power. The third function that I wanted to look at is f of x equals e to the x. And then no more definition for a while, the definition of the limit for a while. So let's find f prime for this function. Limit as h approaches 0 from e raised to x plus h minus e to the x divided by h. So is this okay? Yes? Perfect. Okay, so let's review one property of the exponential notation. If I have a to n plus m, nm, what does this, where does it come from? It's a product of a to the nth power times a to the mth power. So going this way, I copy the base and add the exponents, correct? So this is basically a relationship going back and forth. Is the same from left to right, from right to left. Okay, so I'm going to use this here. And what will you say? I should write limit as h approaches 0 e to the x times e to the h minus e to the x. Perfect. Okay, now what? What is the next step, do you think? Look at the terms in the numerator and say, oh, I know you're going to...
Cross out the e to the x.
Say it again.
Cross out the e to the x.
No, I cannot do that. Yes, I have to factor it out.
Yeah.
So this will be limit as h approaches 0 e to the x divided by, and tell me what it is left in parentheses. Very good. Now you see there are two pieces in here. This is one piece that has h in it. And this is another piece, which is a product, right, of a constant. This does not depend on h. And we know one of the rules, the limit rules or laws, that allows us to put a constant in front. This is like 3. It does not depend on h. So this is e to the x times limit e to the h minus 1 divided by h as h approaches 0. We do not have enough tools to deal with this algebraically or using calculus, but we have a perfect tool called graphing calculator, in which let's plug in parentheses e raised to x, we don't have h in the calculator, minus 1, close the parenthesis, and divide by h, which in this case is x. Yes, we can graph and take a look and so on and so forth, but all I'm interested in is plug in 0 from the left and from the right, approaching 0. Of course, I cannot plug in 0 per se. So I'm going to say negative 0.001. And then I'm going to say positive 0.001. I'm going to use 0.000001. And I'm going to use negative 0.0000001. Okay, and I would like you to make a decision. So what is this limit as h approaches 0 from either side from e to the h minus 1 over h. Perfect. Thank you. So if this whole thing is 1, what is the answer? Thank you. So the answer is to e to the x. And I hope we will remember moving forward that the derivative of e to the x is itself. This is not going to be the same thing when we get to that. Do not jump into conclusions. This will not be the same thing. So if the base is not e, the situation changes. So we're going to get to that later. Okay? But specifically for e to the x, that's the answer. Any questions? Any questions? Okay, I would like us to choose a couple of examples, some problems. So we are on page 181. So we have all sorts of different situations here to differentiate. I would like to look at some word problems as well in a minute. But let's practice the power rule, it's called. And then we'll move on to the product and the quotient rules. But for now, let's choose something from here and a couple of word problems. Okay, I will choose 18. And this is on page 181. And 18 has y equals the square root of x times x minus 1. At this point in time, we do not know how to differentiate a product. So what we have to do is distribute. Remember, this is x to which power? Excellent. So when I distribute x to power 1/2 to x, I get x to 3/2. Would you agree? Copy the base, add the exponents. 1/2 plus 1 is 3/2. And then minus x to 1/2, because I have to also distribute it to -1. Will that be okay so far? Are we okay, everyone? Okay, perfect. So now I know how to differentiate this. So y prime also can be denoted by dy over dx, the derivative of y with respect to x. And I will apply the power rule twice. I will bring down 3/2. Subtract 1 from the power. 3/2 minus 1 is 1/2 minus. And I know what this means, right? It's the square of x, so it's 1 over 2, the square of x. You can continue and try to simplify this as 3 the square of x divided by 2 minus 1 divided by 2 the square of x, and find these common denominators being 2 the square of x. And this will be multiplied by the square of x. So this is 3x minus 1. And this is very useful. And you'll see for chapter 4, this is very important. Okay. Any questions? Any questions?
Can you write it as?
Yes? You mean this final form?
No. Can you do 1/2 x to the -1/2? Would that be wrong or?
Instead of this?
Yeah.
Yes, it's fine, but if you want to fully simplify it for what follows in chapter 4, you need this form.
Okay.
At this point, it will be okay, but in the next chapter, it will not. Okay. Any questions? Okay, so I'm looking at a word problem. I let you choose if you'd like to discuss the equation of a motion of a particle, if that's okay. Or we can look at a second-degree polynomial, or both. Okay, so let's look at 48. We're going to look at both. On page 182, We are given the equation s of t equals t to the fourth minus 2t cubed plus t squared and minus t. S is measured in meters, and t is measured in seconds. Find the velocity and the acceleration as function of t. So we want the velocity and the acceleration. So how do I determine if I have the motion function? How would I determine the velocity? Exactly. So this would be nothing else but the first derivative of the distance function or the motion formula. Okay, so let's do this together. We bring down 4 and subtract 1 from the power. We bring down 3, multiply by -2, -6, and subtract 1 from the power. And of course, we bring down 2 and subtract 1 from the power. And what is the derivative of -t? -1. That's the slope of -t. The rate of change of -t is -1. Any questions so far? Are you with me? Any questions? Eddie, any questions? Is this okay? Everyone? Yes? Okay. So the acceleration can be written as the velocity prime or the second derivative of the acceleration of the distance. Okay, so let's determine this. We bring down 3 multiplied by 4, 12t squared. We bring down 2, -12t, and we differentiate 2t and get just 2. Is this okay? Good. Part B. Find the acceleration after 1 second. So we're asked to determine the two functions, and we did. We found the velocity function, and we found the acceleration function. In part B, they want us to determine the acceleration at 1. What do I do? Plug in 1, so this is 0, right? 12 minus 12. So this is 2. Measurement unit for the acceleration. Remember, it's a rate of change. So it has to have 2 measurement units, one coming from the top and one coming from the denominator. So this is the rate of change of velocity with respect to time. So what is the velocity measured in? Meters per second. And what is the time measured in? So it's meters per second squared. Part C, graph the position, velocity, and acceleration functions on the same screen. So we can do that if you like. Let's do that quickly. So in y equals, oh please. Okay. So in y equals, let's put in those just to take a look at them for a minute. So t to the fourth, x to the fourth, minus 2t cubed, minus 2t cubed.
Okay.
Oh, I forgot. I clicked on the minus, but it didn't take it. Thank you. Okay, and then plus t squared minus t. That's the distance. Now the velocity 4t cubed. And of course minus 6t squared. Plus 2t. And minus 1. And finally the last one, 12t squared. Minus 12t. And then plus 2. And here they come. So here is the distance. Here's the velocity. And here's the acceleration. I don't think that here, I'm going to let them know, because the colors don't show up. I think we don't have the full software. I'm not really sure why, but normally on the other computer where I teach the other class, it shows it in different colors, and it's kind of difficult to see.
So that's the TA plus silver, and one with the colors plus CE.
No, it's the software. They downloaded a different software, I think, than the one I asked. But that's okay. Okay, let's take a look at also the second derivative. Yes, 63 on page 183. We're asked to find the second degree polynomial. Find the second degree polynomial p such that p of 2 is 5, p prime of 2 is 3, and p double prime of 2 is 2. Let's see how we address this issue. So p of 2, they say it's 5. P prime of 2, they say it's 3. And double prime of 2 equals 2. And then I would like to look at a graph of the derivative and function and the derivative. Okay, so can anyone give us a general form, the most general form of a polynomial degree 2?
X squared.
Ax squared plus bx. That's it. This is the most general form of a polynomial degree 2. Very good. So how many variables we see in this polynomial? Or how many unknowns I have? Yes, 3. A, B, and C. Once I determine A, B, and C, the polynomial is fully determined. There is not another option, right? It's going to be a unique possibility. Good. So how many equations do I need to have in order to solve for 3 variables?
3.
Yes. Okay. So please give me the first equation. Anyone?
2x squared.
Right, but it's 4, right? 4a, then
Plus 2.
plus 2b, very good. That's it. Thank you for the first equation. I need the second one, please. Before we determine the second one, we still have to find p prime of x. Can anyone give us p prime of x?
2a.
Very good. Plus? Good. So can anyone now give us the second equation?
4a.
Very good. Perfect. So now let's determine the second derivative. What is the second derivative? Perfect. So then I need a third equation, which is, it doesn't have x in it. There is nothing I can plug in. So 2a equals 2. So I'll start backwards, of course. How much is a?
2.
One more time. 1. Perfect. So let's plug it in the second equation. So we have 4 plus b equals 3. So can anyone give us b? Very good. And now in the first equation, I'm going to replace a by 1, b by negative 2, and hope that you will give us, or someone will give c. Very good. So this is a unique polynomial. X squared minus b, I'm sorry, I meant to write x, of course, and plus 3. This is the unique polynomial that fulfills the given conditions. There is no other polynomial that has p of 2 equals 5, p prime of 2 equals 3, and p double prime of 2 equals 2. Any questions?
For
Yes?
so you plugged in 1 and got 4 plus b, which equals 3. Then you plugged in 3 for a on top.
A is 1. I can plug in 3.
Right. So you went to a.
So I have 4 B is -1. 2 times -1 is -2.
Okay.
And then C, and then 5. So this is 2 subtracted from 5. 3.
Oh, you subtracted 4. Okay.
Is that okay?
Yeah.
Everyone? Yes? Any questions? Okay, so before we continue to the product and quotient rules, I would like us to look at a function like problem 68. At what numbers is the following function g differentiable? And we are given a piecewise defined function. Give a formula for g prime and sketch the graphs of g and g prime. Let's see how this works. So this is problem 68 on 183. And we have g of x, piecewise defined function 2x for x less than or equal to 0, 2x minus x squared for x between 0 and 2, and 2 minus x for x greater than or equal to 2. We know that a function is not differentiable in which situations? Say it again. Cusp, corner, vertical asymptote, or? Yes, discontinuous. Very good. Cusp, corner, vertical tangent, and discontinuous function. Those functions will not be differentiable at those points. Perfect. Okay, so let's find the g prime of x. Can anyone give us g prime of x for the first branch? 2. I cannot put the equal symbol just yet. We'll see in a moment. Okay, so can anyone give us the derivative of the middle branch? 2 minus 2x. And can anyone give us the derivative for the last one? -1 for x greater than 2. Notice that I cannot put the equal symbol yet. So the middle one did not have the equal symbol. That's fine. I don't have to worry about anything. But the top and the bottom ones have the equal symbol, but I cannot put it in, and I'll explain in a minute. Ready? Okay. So let's continue now by graphing this function, g. Well, I know that this is -infinity to 0. I know that this is 0 to 2, and I know that this is 2 to infinity. I need to identify its domain first. Can anyone give us the domain of g? So I can put it in the table. Do we all agree with -infinity to infinity? Everything. There is everything in there, right? Okay. We don't know whether the function is continuous, though, but everything is there. It's defined everywhere. Okay. Now I need 0 and 2 in the table for sure. I will copy the necessary symbols. Remember, this is bracket to the left under 0 and parenthesis to the right. And parenthesis under 2 and then bracket to the right. I will copy the function just to make sure that I'm not forgetting where I'm plugging it in. To the left-hand side of 0 in 2x, in the middle to 2x minus x squared, and to the right to minus x. Okay, so I'm going to plug in into x, I'm going to plug in -1. What do I get? Perfect. I'm going to plug in 0. What do I get? Awesome. I'm going to plug in 0 on the other side. 0. I will also plug in 1. 1. I will also plug in 2.
0.
Good. I will also plug in 2 on the other side.
0.
Very good, thank you. And I will also plug in 3, and I get?
-1.
Very good. It appears that the function is or is not continuous everywhere.
It
It
is.
is, because these two numbers are the same, and these two numbers are the same. They don't have to be the same under 0 or 2, but the left and right limits are the same. Perfect. Before we add the second row for the derivative, I would like us to graph g of x. And please pay attention, I need to graph g of x. And immediately under this graph, we will graph g prime. So the y-axis have to line up, and the values we're going to use, they will be the same for both g and g prime. Okay, so I see that I have to plot -1, -2. I have to plot 0, 0 with a full point, and that's the first piece. The second piece starts at 0, 0. It is 1, 1, and it is 2, 0. Open, but I have to come back and close it. But this is a quadratic function opening downward. So this is the graph. And the last piece, 2, 0, and 3, -1. And this is the graph of g of x. Let's analyze a little bit see what happens here. Do you think that at this point there is a unique tangent? In other words, the slope here and the slope here will be the same. Don't answer just yes. Do you think that here, at this point, the function would have just one slope? The same tangent here and here with the same slope? No. But what about the first one? Very good, very good. But definitely here, at this point, at x equals 2, the function would not be differentiable, which means that the derivative will not be continuous. Perfect. So let's come back to our table and finish this up. So as we headed here, because I could not close, I could not put the equal symbol, for now I'm going to do this. Because I don't know what happens here. In a minute, we'll figure it out. So now, in this territory, the function is 2. This territory is 2 minus 2x. And in this territory is -1. That's our derivative. So let's plug in -1. What do I get for the derivative when x is -1? Very good. What do I get for the derivative when x is 0? Perfect. On the other side, what do I get for the derivative when x is 0? Perfect. Here, 2 on the left-hand side when I plug in 2 in this expression. Very good. And on the other side, when I plug in 2, what do I get? Good. So this is absolutely clear that the function is not differentiable at 2. The derivative on the left is -2. The derivative on the right is -1. But here, since these two are the same, there is no need to leave a gap. This is 2. I can go back now and put the equal symbol back where it belonged. Now I know for sure that that is x less than or equal to 0. That's correct. But I could never put the equal symbol at -1. For this one, I meant, at 2. There's no equal symbol here. This is -1 on one side, and it's -2 on the other. The function will not be differentiable, and the derivative will not be continuous, as you see. It's not continuous. Okay, so now we're ready to graph. So at -1, the function is 2. At -1, the derivative is 2. At 0, the derivative is 2. I did not put the 1 in here. Let's also come up with 1. So 2 minus 2 is 0. So obviously here, the derivative is 0. So at x equals 1, this will be 0. Okay, so first let me finish the left-hand side. This is the first branch for the derivative, 2. Then we have at 2 is 2, at 1 is 0, and at 2 is negative 2. Two at 0, 0 at 1, negative 2 at 2. And finally on the other side, for the third branch, let's do this in blue, is negative 1 and continues forever. So this is g prime of x. Where the derivative is not continuous, the function is not differentiable. Any questions on this? Any questions? Okay, 3.2, product and quotient rules. Product and quotient rules. We cannot invent anything here. I'm just going to show you what I like to use, the method I like to use. Your book and every other book is maybe slightly different. They all mean the same thing. They may be slightly different. So if we have a product of two functions that we want to differentiate, I like to keep them in the same order, not twist them, but it doesn't matter. You use the method you like. F prime g plus fg prime. So this is function 1 times function 2 prime is 1 prime times 2 plus 1 times 2 prime. This is just something that works for me. You can say the book shows here basically these two reversed. It doesn't matter. It's the same thing. So whatever works for you. It's a matter of habit for me, of course, to keep 1, 2, 1, 2. Now, if we have a quotient, the numerator is the same but with minus in between, identical formula, f prime g, fg prime. However, the denominator is squared. So if we have 1, 2, not just f and g, it's 1 prime times 2 minus 1 times 2 prime divided by 2 squared. It's up to you the way you want to remember it, those two. And I like to practice now with a couple of problems from page 189. Let's start with a product, a simple one, number 4. So we have g of x, which is the square root of x times e to the x. So this is a product of two functions. There is no other way but use the product rule. If I want to find g prime, I have no other way but differentiate using the product. So the first function prime, 1 over 2 the square root of x, we proved it together today, multiplied by e to the x, plus the first function times the second function prime, which is e to the x. I do recommend in this situation here, for chapter 4, factor out e to the x, find the least common denominator, and multiply, and get the top as being 1 plus x. So I would write it as e to the x, x plus 1, over 2, the square root of x. Is this clear? Were you able to follow? So I pulled out a e to the x, and then I have 1 over 2 the square root of x plus the square root of x, but I need the least common denominator, so I need to multiply that, and I swallowed the 2. I was hungry. Sorry. the least common denominator is 2 the square root of x, not just the square root of x. My apologies. So then I have 2x plus 1. And you'll see why this is so important for next chapter. Any questions on this problem? Is this okay? Is it okay? Can we move on to a quotient? Don't let me move on to something else if you have questions on this, or if you say, I need to see another problem. I'd be more than happy to stop it. Yes, right? Yes?
Are you looking for that as like a final answer in this chapter?
Yes, this is the final answer. It will be specified. So, very good question. On the next test, I will make sure that when you can simplify something, I'll say, please simplify it fully. When you can, I'm going to say, you don't need to simplify.
Okay.
Very good question. Thank you. Anything else? Other questions here? Yes, please, hon.
For the quotient rule.
Yes.
Could you like explain how it's like derived into that rule?
Yes. I can sit down with you after class if you'd like to see the proof. I can, for now, just quickly show you the proof. I think there is. They showed it in the book, at least one of the or the other. So it's all this, right? But I can sit down and explain this to you. It's not a big deal. Okay. So if you want to do that. Okay. Let's look at a quotient. Let's say problem 14. Same page. 189. We have y equals x plus 1 divided by x cubed plus x minus 2. Again, this time it's a quotient. The function at the top is x plus 1. The function at the denominator is x cubed plus x minus 2. We cannot reinvent anything. We have to use the quotient rule. Top function 1, denominator function 2. If you like this method, if not, look, use the method in the book. They only reverse the last product. Okay, so this is also dy over dx. Do I need both notations? No, I just want you to get used to the second notation because when we get to implicit differentiation, we have no choice. We have to use this. It's wiser to use that. Okay, the denominator is x cubed plus x minus 2 to the second power. And the numerator, can anyone give us the derivative of the numerator? The slope, 1 times the denominator, x cubed plus x minus 2, minus, I have to copy the numerator, and now I have to multiply it by the denominator prime, or the derivative of the denominator. So I bring 3 in front, I get 3x squared, and plus what?
1.
Very good. 3x squared plus 1. We agree? I have to continue and simplify it a little bit at the top. I will not leave it like this. So this is x cubed plus x minus 2. I will distribute. Don't forget the negative sign in front. So a negative 3x cubed, negative x minus 3x squared, and minus 1. Everything over x cubed plus x minus 2, everything squared. And I will continue. These two go away. And I have a negative 2x cubed and a minus 3x squared and minus 3 over x cubed plus x minus 2 squared. Yes, I prefer removing the negative. Even if just, if the leading coefficient has negative, I will put it in front. I don't care about the rest. So 2x cubed plus 3x squared and plus 3 over x cubed plus x minus 2, everything squared. Any questions on differentiating the product or quotient?
Can we do another product?
Yes.
Fine.
Yes, of course. Let's look at another product. Yeah, 12. And this is f of x equals 1 minus e to the x and multiplied by x plus e to the x. If you are looking in the book, I changed the z into x only because the way I write z is confusing. Could be confusing. Here you could say, wait a minute, you don't need to use the product rule. Just multiply these out. True, but we want to practice the product rule. So let's do that. So this is function 1 and this is function 2. So then f prime of x will be function 1 prime. We will have to write negative e to the x. And we copy the second function, x plus e to the x, plus. We copy the first function, 1 minus e to the x, but we have to differentiate the second function, 1 plus e to the x. So now, is everyone with me? Is this okay, everyone? Yes? So the product rule says that we have to differentiate the first one and copy the second one, and then plus, we copy the first and we differentiate the second. Is that okay? So now, yes, we have to distribute and simplify as much as we can. So this is negative x e to the x minus e to 2x. We copy the base at the exponents. E to 2x plus e times e to 2x is e to x times e to x is e to 2x. Here I distribute, but this is like 1 or a minus b times a plus b, which is a squared minus b squared. Copy the base at the exponent. And I can only combine these two. There is nothing else I can do here. So the final simplified form will be negative x e to the x minus e to 2x minus 2e to 2x and plus 1. And that's the final form. Any questions? Please, Eddie.
Does it make a difference if you add a product and a quotient?
Absolutely. Very good question. So can you think of a problem? A function? Let's say x squared times e to the x divided by x squared plus 1. Would that work? Perfect question. Perfect question. First I have to differentiate. I'm differentiating using the quotient rule. But when I differentiate this part, I have to use the product rule. So let's do that. Excellent example. So we have function 1 and we have function 2. The denominator is x squared plus 1 squared. And now the numerator. Let's write it out first without calculating anything yet. So I'm going to write x squared times e to the x prime times x squared plus 1 minus x squared e to the x and x squared plus 1 prime. So I did not differentiate x squared times e to the x. I did not differentiate the top, but I did not differentiate the bottom. X squared plus 1. I just want you to see it first. Please, the risk here is, that someone may be tempted to simplify these two. Cross this one out and cross the power out. Is that correct? No, because this portion, x squared plus 1, is part of a term, because these are two terms. The first term minus the second term. So I cannot remove a piece from a term with a piece from a factor. So please be careful with that. Okay, so now we can finalize this. I have to differentiate this product. Now this is function 1 and this is function 2. First function prime, 2x times the second one not differentiated, plus x squared times the second function prime. And now I copy x squared plus 1 minus x squared e to the x, and now I can differentiate the denominator as 2x. So every time we have a combo like this, you have to be very careful where you start and what you do step by step. Does it make sense? It's not fully simplified. We will work on it and simplify it as much as we can. Ready to do that? Yes? Okay. So then, please don't cross out anything. First we simplify by this. First of all, we distribute. X squared distributed to these two. So 2x cubed e to the x plus x to the fourth e to the x plus 2x e to the x plus x squared e to the x minus 2x cubed e to the x over x squared plus 1 squared. The only two terms that go away are these two. And yes, I will factor out x e to the x. Can anyone give us the quantity in parentheses after we factor out x e to the x? From here, x to the third. From here, plus x. And from here, plus 2. So we factored out e to the x and x. So x cubed, x, and 2. And there is nothing else we can do here. This is it. Any questions? Is this okay? Okay. Let's look at two problems. Something like this, and I let you choose whatever you want. And also I would like to work on a graph. So here we're given information and we're asked to find h prime of 2. And here we are given graphs and we're asked to find v prime of 5 or p prime of 2, whatever you want to choose. So, which is your preference here? A, B, C, D? Okay, very good. C is f over g. So that's problem 44 on page 190. Okay, so we have part C. It's h of x, which is f of x over g of x. And I'm going to have to copy the information given. So f of 2, they say, is -3. G of 2 is 4. F prime of 2 is -2. And G prime of 2, they say, is 7. The question is asking us to find h prime of 2. Any suggestions on this?